All right, this video is going to just give an introduction of simple harmonic motion. Simple harmonic motion is a motion that sort of repeats itself over and over again. A very common type of example is a mass in a spring example, where you have a certain equilibrium point and you have a displacement. Let me bring up a little example here on a website that I have. So if we were to take a spring and we put a weight on it, and we were to like pick it up or stretch it out and just let it oscillate, like let it go, it would just continue. Now, if we're ignoring gravity and friction, not ignoring gravity, but ignoring friction, this thing would continue on, forever. You can see that it repeats itself. And if you look at, this equilibrium position, this mass is always going towards this equilibrium position, which is its position if it's just resting, right? And the highest that it goes, right, is going to be the displacement that it has. So the space from the equilibrium position all the way to its high point is its displacement. We can kind of think of that, think back to sine or cosine graphs, think of that as like the amplitude, right? So we have a maximum displacement that we have, which is going to go, from the middle all the way to the top, or to the bottom. We could have like a positive or negative displacement, and that's pretty much what we're talking about with this spring example and a very simple harmonic motion example, right? So if you were to take this over time, you were to start a watch and track this position of this mass over time, it would look like, like a sine or cosine wave, right? It kind of looked like this. So, you just to kind of fill some things into your notes, if you have this little spring and mass example, right, this little line right here, we would just label as, like this is the equilibrium position. The position of that mass if it's just hanging there, right, at rest. And then we can see here that we'd have a displacement. So from the distance from this equilibrium all the way to the top would be like a displacement, the amount of displacement from the middle to the top, or could be from the middle going down. It's that amount of space, right? This would be like you could think of this as a positive displacement, and you could think of from here down to the bottom as like a negative displacement. And so if you talk about this type of motion, this type of periodic motion, you can model this with a sine or cosine graph, and that's what we're going to try to do here. So just to start things off, look at a pretty simple example here, that we have a table, right? So we have a table here, we have time, and we have the amount of displacement in inches. So at 0 time, we have a displacement of negative 0.5 inches. At 1 second, we're at 0 displacement, so it's right in the middle. At 2 seconds, we're here. At 3 seconds, 4 seconds, etc., etc. So it says find a trig function to model the displacement of this oscillating spring. Okay? Well, the way that we're going to do this, the first thing we would do is just graph. The easiest way is just to graph these points, the data that we have. And then we're going to try to hook that up with a sine or a cosine equation. So let's first graph it. If we're going to graph this, let's just say we have x and a y-axis, and we have, if we look at the displacement, it looks like the maximum displacement is 0.5, right? It goes up to 0.5 and then goes all the way down to negative 0.5, assuming those are the high-low points, okay? So we would say, all right, well, this top point is going to be 0.5. The bottom is going to be negative 0.5. And if we start to make little intervals here, right, this would be 0, 1, 2, 3, 4, etc. And we can plot these points. So at time 0, this is going to be the time axis, and t, we'll call this d. At 0, we're at the bottom at negative 0.5. At 1 second, we're at equilibrium right at 0. 2 seconds, we're at the top. 3 seconds, we're back to 0. 4 seconds, we're right here. Okay? So this looks like a sine or cosine wave, right? And we can sort of graph that out. And this pattern is going to repeat over and over and over again. Okay? So we want to graph it first, and then we're going to model this with an equation. The question is, how do I model this? So we've done problems like this before where I give you the graph and you have to come up with what is the equation for that graph, right? You have to think about, does this look more like sine or cosine, or what do I want to use here? In this case, I would say this looks like a cosine, right? Because it's starting at the bottom or it's starting at the top. That's kind of an indication of using cosine here. So I'm going to use cosine. Some of the other characteristics that I can see here is that the amplitude of this is 0.5, right? The period, right? The period, or in this case, the time it takes to start to repeat itself is going to be 4 seconds, right? At time 0, it's at the bottom, and at 4 seconds, it's at the bottom again, traveling up. So this is the period. The period is 4 seconds. So we know the amplitude, we know the period, and this is going to be enough to figure out what this equation is. So we're choosing to use cosine here because it's starting at the bottom. So let's say this. We're going to use cosine. We're going to say, let's just call this vertical axis y here. Make it simple. We'll say that's y. So our equation is going to be y equals, and it's going to be some sort of amplitude, cosine, and it's going to be like b times t, or like bx, right? We need to figure out what is the a value, what's the b value. We don't have any sort of shifts in this graph. It's kind of a simple graph. So what is the a value? Well, the a value is going to be negative 0.5 because it starts at negative 0.5. So negative 0.5, right? It's a negative cosine graph. Now, what is the b value, right? Well, we have to use the period there. The period is 4. So how do we figure out the b value? Let me just bring up a new page for this. So if we know that the equation for this, the period is always, for sine or cosine, 2 pi divided by b. And we know in this problem that the period is 4. So we can plug that in and we can say 4 equals 2 pi over b, right? So what is b? We can solve for that by, let's see, we could multiply by b on both sides of this equation so that we get rid of it on the right hand side. That would leave 4b equals 2 pi, and then we could divide by 4. So divide by 4. So therefore b is equal to pi over 2. That's what the b value is here. It's pi over 2. So go back to our question. The b value right here is pi over 2. So my equation is going to be y equals negative 0.5 cosine pi over 2 times t, or x, or whatever your variable you want to be. So there we go. That's a trig function that models this graph and this motion. If I go to Desmos here, I can just quickly double check my answer. So the equation that I had was, let's see, y equals negative point, well, let's try that again, negative 0.5 cosine of, let's see, pi over 2 times the variable. Desmos probably wants an x there, so I'll put an x. And so the graph that it gives us should model what we're seeing in our table. You can see 0 is negative 0.5, 1 is 0. At 2 seconds, we're at 0.5. 3 seconds, we're at 0. 4 seconds, we're at negative 0.5, and so on. So you can always graph what equation that you got and just make sure it makes sense in your problem.